All right, we are live. This is Hangops. It has been a while since I've hosted. Big shout out to Chris Weber for keeping things going while I had a number of fancy business meetings occupying this time slot. So it is April 24th, 2015. We are live. We are here. We have a great crew today to talk about some immutable idempotent infrastructure as code, triple IOC. No. Actually, we're here to talk about another pretty cool tool from the HashiCorp folks called Terraform, sort of a cloud agnostic declarative way to define your cloud resources. We'll start with some intros. We'll start on my left, which is we have a small cluster of Mozillians. They can start, I guess, on their left. Frosty.
What do you think the group noun is for
collective noun?
a collective noun? A conundrum of Mozillians. Hi, I'm Dan, Frosty on all the things. I am one of the conundrum here, and I am apparently now employed as a HashiStack administrator for Mozilla. So, as a result of that, the topic of conversation on today's Hangops is relevant to my interests.
Hey, I'm Rob Helmer. I work on the crash reporting server at Mozilla, which is something we're moving to AWS using Terraform to do that. So.
Hey, I'm Lon. I work on internal tools at Mozilla, including the crash reporter and said HashiStack. Yeah,
That's it.
Awesome. Kevin?
Yeah, I'm Kevin Knuckles. I worked at a place called Bano. We got acquired by a place called Jack Henry & Associates. We make things for banks and mobile apps and ad engines and whatnot. And we're heavily invested in Packer and Terraform in an auditable environment. So I'm part of a big team working on that right now.
Awesome. And last but certainly not least, Paul, I gather that you know a thing or two about this Terraform thing we're going to talk about.
Yeah, I've heard of it once or twice. Yeah, my name's Paul. I, since the beginning of the year, have been employed by HashiCorp to work on Terraform full-time, amongst other things, but that's kind of my primary role right now is Terraform core. So I'm still kind of in, I see myself still kind of in ramp phase. Terraform's incredibly complex, especially deep in its core. But I've been learning as much as I can, as fast as I can, and it's been a fun ride so far. I'm excited to talk about it.
Awesome. And you did get a little fuzzy for a second, but you're back clear. So if you would, what is the elevator pitch and vision of Terraform?
Yeah, I was thinking about that on the way when I was kind of walking around this morning, and it's interesting that I think a lot of our documentation describes it sort of in active verbs rather than attempting to sort of create a noun phrase that summarizes what it does. I think you did a pretty good job in the intro, actually. But essentially, it's a declarative configuration language that allows you to create and plug together diverse cloud resources. For me, I think the through line sort of metaphor, which is actually at the core of Terraform, is graph building and graph traversing. So what you're doing when you're creating Terraform configuration is you're declaring a graph structure, a set of nodes and dependencies that Terraform actually internally builds into, like, what you would think of as the classical sort of graph structure in computer science, and then so it's about building and then traversing the graphs. That's what Terraform basically does, is use the information on the dependencies to do everything in the correct order and plug everything into each other. So that's the idea. I have a coughing dog in the background. Sorry about that.
I think it's like the rug and the Big Lebowski, like it really brings the room together.
Yeah, exactly.
Every single API that you hit that represents my infrastructure, it sets up the right order.
Cool. So I certainly have had some hands-on with it, but I talk on here all the time. So Kevin and our gaggle of Mozillions. Why don't you sort of talk about why it caught your interests, maybe why you chose it over other tools that might be available uh, to help you sort of code your clouds, and we'll just kind of just sort of talk about experience, and all that.
I can speak to that. I mean, years ago, I worked with a lot of chef, and there were a couple of tools, one of which I wrote called Whisk, or I helped write with a guy, Nick Grayson, basically for standing up like servers. And it seemed to me like there needed to be something that fired up infrastructure that configured all the things like Finzi was talking about. And I had dreamed up something along the lines that was declarative, like Terraform currently is. And the day that I found it, it was just like, oh man, like Mitchell started it. Great, like I'll learn Go. And now I think 8, 9 people at our organization learn Go and have been working on plugins for Marathon and Mesos, and it just I think the thing that I like most about it is that it's declarative, much like a SQL engine, right? So I declare these are the things that I need and the dependencies between them, and it infers the execution path based upon the graph of dependencies, such that and beyond that, it also like helps solve the drift problem, so that if there's some specific resource out there in the wild that represents my infrastructure that is not quite like what the configuration states, it will then go and fix that. So at least on a large team, especially in an auditable environment, it's really important to have infrastructure as part of our change notes, right? So we need, it seems like change notes go out for code bases a lot more than they go out for infrastructure. So that's what we're shooting for. And like I said, it just brings the room together. It's a well-hardened declarative tool for doing effectively what I needed it to do.
So from our perspective, we didn't go into this with, I think, any particular preconceptions about what Terraform was or wasn't. I think our approach was a bit more pragmatic, which was that we need to get out of a data center and into Amazon. Not by our own choice. It's a financial decision that was made at the upper echelons of our shady organization. And so we said, okay, we're going to leave the data center and we have to go into Amazon. We have a very aggressive timeline to do it. So for us, we were really trying to find, I hesitate to use the word shortcut because I don't think anything's a shortcut, but we were trying to find a way that we could use a tool to do some of the heavy lifting for us, right? So yeah, I mean, absolutely, we could spin up instances and do security groups and so on and so forth, and we could write tons of artisanal scripts or lovingly handcraft JSON blobs into unversioned text areas on web pages. There's definitely, we could do this, it's fine. But Terraform was just like, oh, here's a thing that will help you to not want to kill yourself when you're putting infrastructure into the cloud. And so for us, that I think was the biggest value proposition, was that it did some of the heavy lifting. And then the second element of it, which was also quite compelling, is that it's cloud agnostic. Well, I mean agnostic. It's multi-platform. And so that's interesting too, because we have use case and business case for Heroku at the very least. So being able to manage both Heroku assets and Amazon assets from a single code base is quite compelling. It does other things as well, I think, right? It does.
If we later decided we wanted to use simple DNS, or, I mean, it gives us options going forward for vendor arbitrage that helps us alleviate our own anxieties about vendor lock into AWS a little bit, which is very nice.
That's the case for me too, right? And if there's another provider that has an API that I need, it's really not that hard to write a plugin and go and make it work. Like we wrote one for vSphere, and one for Marathon, right? So we've got containers running on top of vSphere, and that's just, it's nice that it does that in addition to our AWS stuff. I think it'll.
One of the other concerns for us, we were looking at the different tools we could use for this. CloudFormation, we knew most of our infra was going to be on Amazon, and we frequently get asked, like, why not go with Amazon's tools? Amazon's tools suck to use. They're miserable. Even the things that they think are super candy-coated for developers are not particularly friendly, fun to use, easy to work with. But HashiCorp has a history, albeit a relatively brief one, of making things that are really, really good for the developers, the ops, the infra engineers working on it. And while Terraform was kind of behind the state of Amazon's tools, and necessarily will always be, we felt that it was getting better faster. Like we could see that 6 months from now, a year from now, that this experience was going to be really like worlds ahead in terms of the ergonomics for us working on it. Like Frosty said, just hand editing JSON files or hand editing YAML files and running a converter script to make JSON files that we then drop into a web form was just unpalatable. And I could just see production errors coming from that, coming from missing commas, or just silly stuff that isn't really talking monkey work. Yeah.
We had our we were speaking with an Amazon solutions architect earlier this week, and we mentioned that we needed to deal with Heroku as well as Amazon. This mystified it. Well, why everything's in Amazon? Why would you need to put anything in Heroku? Just use Elastic Beanstalk. And
did you ask him if he'd used Elastic Beanstalk?
Exactly.
I think we stopped talking about Elastic Beanstalk.
I think we did.
I think that's about the time we stopped talking about it.
I think that's when we shut that conversation down. And so yeah, so that's it. And that's one of the beautiful parts, as Lon said about really all of the HashiCorp tools, is that they're getting better faster than a lot of the things that they're actually controlling. Not that the Heroku experience is bad, no, right? Or not that like the Azure experience or whatever is bad necessarily, but the rate at which that developer or operational experience is increasing, that velocity is not matched by the HashiCorp tools. So,
and inside Mozilla right now, the current scope of our work is AWS, and then we added Heroku a little bit. We have some sites that are 4 nodes, 5 nodes, or short-run marketing sites where we do Heroku and an S3 bucket and CloudFront for CDN. But there are other projects that we could see conceivably becoming the platform for that do use Azure, that do arbitrage external services. So from a long-term planning, it looked good. And the final killer feature for us was modularity, which any form of modularity in terms of being able, the good example of this is the console server scripts, where we can point to already pre-written Terraform files in order to get a whole cluster of console running in a moment. We can abstract away with those modules sort of standard web app deployments, and it makes it significantly easier than, again, what would end up being a pre-processing tool on top of Amazon's JSON stuff. Yeah. Yes, those were
as well.
big reasons.
And I think that one thing that we've adopted as far as modules are concerned is making sure that the infrastructure that gets stood up inside of the module then effectively has a last smoke test before the outputs go out, right? So that the test is right there next to what gets built inside the module. I don't know what other people do, like as far as tricks within their modules for effectively post-deploy verification, but that's worked well for us. I also like the fact that the modules themselves are effectively composable, right? Like once we've made one, it's effectively done, right? Personally, I'm curious to hear from Finzi, like how they use it internally.
the dog food story.
Yeah.
Yeah, I mean we do. Yeah, so we do drive our internal sort of operational infrastructure with HashiCorp tools, as you might expect. Uh, and yeah, I think it's less sort of exciting, or sort of we're not doing anything super exciting or special. At the end of the day, we're a relatively small startup, so we're not managing like thousands of nodes, quite yet. So yeah, I mean, I think you'll see us sort of running master versions of all of our tools, and dogfooding the bleeding edge, and trying out new features. I mean, so we were kind of hashing out the create before destroy sort of lifecycle events early on. So that's most of our current infrastructure is modular and sort of deployed via we're on AWS, deployed via like auto scaling groups with create before destroy sort of workflows to facilitate zero downtime deploys or low downtime deploys. So I did want to go back to the conversation about CloudFormation, because that's my history as well. I was in my prior organization was pretty heavily investing in CloudFormation. And I talked to a lot of people for whom that's the mental model they're moving from. They're very similar spaces, sort of declarative infrastructure as code. And for me, the killer feature of Terraform, as opposed to CloudFormation, is the plan step. If anybody who watching has used CloudFormation in anger, that's the scariest bit. You can do a lot of the declaration of infrastructure and stitch stuff together, and plan changes by writing them in code. But at the end of the day, there's only one execute step, and it does not tell you what it's going to do. And you think you might know what it's going to do, but having that Terraform plan to lean on is just game-changing. When I first saw Terraform as a tool, that's how I started to get involved with it, was the idea that like you build the graph and then you can inspect the graph before you execute it. Is just so huge.
That part of Terraform that you're talking about with the plan step, we built essentially a preprocessor for my organization that uses the AWS CLI. So we compared tooling, and we thought about CloudFormation. We thought about the limitation of actually just letting it go off and learning all of the semantics that it uses to determine how it actually changes the infrastructure, and kind of the onerous activity of doing that. So we didn't use CloudFormation after all, but we did like that AWS CLI was positioned to be that unified, we're going to keep up with all the services. So we built a wrapper around the AWS CLI to just interact with it. It's called the Zinx AWS Automation Tool. It's open source on GitHub. But there's also the keeping up with the AWS CLI. So the AWS CLI may change in the way that it interacts with the services. So now we're in a position where some things aren't returning JSON where they used to, and that's a limitation. So we also were talking to AWS recently, and I made that point to them, and I said, we need it always to return JSON. Just even if it returns just true, like just return just a basic blob. So we ran into that issue by building our own tooling. So this plan step you're talking about, that seems critical, because it's we're going to need to know how that graph gets applied before it gets applied, because maybe it restarts stuff as part of actually applying, and that needs to be considered.
Honestly, in like some really stringent environments, the plan is the most important part of like an auditing step, right? Because you have to have this like change plan that you apply to production, and some places just are not okay without that. That was one of the biggest like thumbs up for Terraform for me. That and the fact that there's a huge community of people swarming on making it nicer.
It's nice, we're sitting around patting each other on the back over Terraform, and rightly so. It's a good tool, but we've, as recently as yesterday, had some problems with the plan, where the configuration files look good. We do a plan, the plan looks good, the graph looks good, everything is where it should be, and then we try to apply that, and something goes wrong. some wacky error from Amazon, some index number that's out of the acceptable range. I mean, something goes wrong. And although the plan looked really good, it did not get applied properly. And you were left with this half-baked state lying around in Amazon, and no good way to get rid of it, because the plan, as it was supposed to have been applied, didn't get applied, and now Terraform is confused. So you have to go in by hand and remove a ton of stuff, and that's a problem. I'd hate to be the Debbie Downer on the conversation.
Well, that
but
yeah,
you
yeah.
got to be aware that that's a potential pitfall.
So we avoided that whole problem by not creating a graph with our tooling, and so we chose not to accept that risk. We just avoided it, and we did it by having a declarative idempotent execution model, but it wasn't a graph oriented. The user actually had to know what they were declaring as they went, and then if they got into an awkward state, they could fix it, because everything was kind of an idempotent individual step. And so that's how we avoided the whole of kind of an awkward dead-end path that we really wouldn't know how to back out of.
And I think it's worth mentioning that, and so yes, that totally sucks. It's actually at developing Terraform core, it's one of the most annoying things is when you end up with dangling resources. I have I have a specific Terraform testing account with every cloud service. And I basically am always forgetting about a dangling resource and paying $5 per day over the weekend or something like that. And I will come in on Monday, I'm like, no! We talked about trying to build a tool that guarantees that it kills every resource in a specific cloud environment for that reason. But yeah, it sucks. And especially it's kind of true of any automation tool, which is if the automation goes in the wrong direction, it can very efficiently sort of shoot you in the foot. But I did want to say that the subsystems exist in Terraform to handle those situations. When you see those problems, those subsystems are malfunctioning. But the model that Terraform's built on considers that situation specifically. So the fact that the plan was different than the apply is for me the biggest kind of bug we can have, and that's sort of a huge problem. The reason I can think of only one instance where the actual graph was different, and that's when it has to do with cycle detection. When things become dangling, that we have a little less control over that, right? So we can execute a plan based on the state of the world as we see it at one point, and then we start to walk the graph of the plan and make calls against AWS. Any one of those calls may fail. And we have less control over that. But we can stop the graph there and continue it at other places. And we do have facilities for sort of marking resources as partially complete or tainted for cleanup later. And those are the facilities I think that aren't robust enough right now. And we'll continue to fix bugs, make them be able to see more things, such that the intended UX there is you're walking through making hundreds of API calls. One sort of fan of the graph fails, and several resources are now dangling. Terraform, the intended UX marks those resources as tainted, and then the next apply or the next plan will know that they're there and then clean them up. So it's definitely we've got a ways to go in a lot of the sort of edge cases. But the model intends for that to happen and for there to be sort of recourse that we can take. It doesn't do it. If it doesn't do it, then that sucks, and we'll fix it.
That's really the thing, is that adopting it as early as we did, it's not 1.0, but it's a lot further towards the tool that I needed than I could have built by myself or with a team. That wasn't our core competency. So honestly, any rough edges that we encounter, there's a PR for, right? Or we come on an issue, and I love Terraform, and I'm going to make it better. So, but yeah, I've had dangling resources, I've had problems. It seems to me like it's worth it. Yes. But one thing I guess I was curious about is how people handle staging UAT in production. Like I know how we do it, but like a lot of the Terraform problems should sort of, if you have a near identical UAT to production, they should sort of bubble up in UAT before you attempt and apply a plan and apply in production. Like, does anyone have a specific tale about how they do that? Like we just pin
That's what we're
patches.
staging, what we're planning to do. um, so just pretty much what you described. I mean, we control things like the environment in like Terraform. There's a Terraform variable for environment. So there's there's a Terraform variable for like the ID of the SSL cert. Like things are different between environments. We use Puppet and Packer together to provision the AMIs that we're going to ship, and then we also, when an ASG spins up, pretty much our all infra is based on like auto-scaling groups, with or without an ELB in front of them. Sometimes internal only ELBs. So when those auto-scale groups spin up a node, we run Puppet one last time, and it just says, okay, what environment am I? Where do I find my console server? What's the host name engine I should be listening to? All that stuff is done. There's like one very light provision step that happens right then. So our plan is to, every time you push to GitHub master, push app code or infra code to GitHub master on the respective repo, we keep the infra side in separate repo, then it'll automatically go to stage. And then we'll look at stage, make sure it looks good, and then basically do a tag. And that's the way we're planning on automating production pushes. So for that, we're thinking of basically just when it's time to go to production, the model we've been talking about is just changing our launch configs to use the new AMI. So the AMI is another Terraform variable. So the production push is basically just update the AMI, do a Terraform apply, spin up some new nodes on each auto-scaling group, and wait for them to go healthy, spin down build ones. That last bit is something, as far as I know, Terraform doesn't do for us yet. Hopefully it will someday, but we're fine doing our own scripting for now to do that, and hopefully, I think with a lot of this stuff, we're hoping over time Terraform will subsume more and more of this. Like if Terraform was able to, on apply, for example, if we could configure it to, create before destroy, spin up new nodes, drain the old ones, shut down the old ones when the new ones are healthy, that would be really cool. But I think we're probably going to strip that part for now. So yeah, I mean, basically the move, the difference between stage and production is very small. It's just a set of variables. That's the model we're hoping to go with. We were also basing this on talking to other people, like how a lot of other big AWS shops do stuff. We noticed when we were looking at the way Netflix does stuff, they do this similar model with AMIs, where they have an AMI they're happy with, and then they flip prod over to that, and they scale things up. They kill the old ones and scale it back down. So that's the model we're looking at. But like I said, we have a real working staging cluster, but we don't have a prod cluster yet. So it's a bit theoretical.
It's definitely theoretical. But the nugget of what Rob said that really stands out, at least for me, is that the difference between prod and stage is a couple of variables.
Yeah.
It's the same configuration files. It's the same Puppet repos. It's almost the same AMI, et cetera, et cetera, et cetera. So we're just saying, if it's stage, then these three variables. If it's prod, then those three variables. And the amount of artisanal, handcrafted bash scripting that we've had to do to get this far has been relatively small. We've got like a wrapper script here, and we've got a provisioning script there. And we're spinning up a console cluster for the first time, for example, to put data into. But yeah, no, we don't have to do as much scripting as we would have had to do, I guess, for in other environments. We don't have to run a ridiculous Jenkins behemoth that has a zillion build steps that could go wrong. Just trying to keep it as simple as possible.
It's interesting. One thing we've attempted to do with Jenkins specifically is make it so that we have a skeleton environment for like our whole Mesos cluster that gets fired up. And then when we change master on that, we run that just by Jenkins to make sure that basically our whole infrastructure comes up before we apply that effectively to staging and going up forward. Um, I've in the past, you brought up the destroy, like so you just like pull them all up and then sort of gracefully drain off the old AMIs. I found deep in the Terraform core that there is a mutex as far as like how many things can occur in parallel. I've thought about exposing that up to the command line so that you could make it so that you could do a Terraform destroy or Terraform apply, but only with parallelism of 1, so that you could do a destroy one at a time, sort of more safely, right? Just like you were talking about, anytime you automate like the destroy of things or anything like that, it's sort of like, well, you hope there's not a bug, especially when you apply it to production, right?
Yeah.
The other thing that we found is that I haven't found a need for anything more complicated than Bash when it comes to scripting anything really, because to me there's just what goes in the Packer script, what gets run in post-launch, and then what I mutate that individual node to, like what its specialization is, like whether it's a Zookeeper node or or a Mesos master or something like that. I guess those are just some experiences that we've had that I wanted to share. Is anybody specifically doing like a Terraform apply and staging in UAT and then in prod? We pin those to specific versions, or we intend to. You're right. Some of this is what I'm talking about is theoretical as well. We're getting closer and closer to it. But.
Yeah, I mean, we're definitely using Terraform apply to make changes to staging. The idea is that we'll do it there, and then if it works there, we'll do it on prod. It should work on prod. One thing something you said made me think of this. With like the safety destroy and such, because we have some services that just necessarily have state, right? Like Console, Postgres, Elasticsearch, they just by their nature they just have state. Pretty much everything else, like all our apps, don't have state. They get their config from Console.
Isn't that not stateless ones? Those are the nice ones.
Yeah. So one thing we've done, split up we started out with one giant Terraform config, one main.tf for our whole infra, which is, I don't know what, 9 apps or something for all the crash reporting various bits and pieces, like RabbitMQ and various front ends and internal processors and all kinds of stuff. So we end up splitting our Terraform config to multiple. I think we literally have like 11 or something directories. Each one has some little main.tf. So you can never accidentally kill the console cluster by trying to spin up a new web app. For example, it's completely separate. The only downside to it really, it works really well overall. The only downside to that is Terraform doesn't have any concept of include files yet. So we have to make symlinks or duplicate resources or things like that, which I think just that one feature alone would be huge.
Includes would be huge.
Includes, yeah, honestly, yeah. I mean, we could script it and like stick it together or something, like that. but I don't think we want to go down that road right now.
What would you be
so we're working around with right now, which isn't great. And we have, like Preston mentioned, we have a wrapper script, so we can say you go in the parent directory of all of them. You say run the wrapper script, and you say you want to apply for this environment for this app, and it will keep Terraform state in sync on S3. It'll apply it. So that helps a bit too. That makes it a little easier to manage a large AWS configuration by having this split up. But yeah, if we had include files, it would be nice actually. It would be ideal.
Nice. But I mean, it's trade-offs. It's just everything's trade-offs all the way down. Yes. Right. I mean, the trade-off there is that we don't have a unified view of our entire infrastructure in one spot, right? Because effectively, each of we call them roles. So like Elasticsearch is a role, and Processor is a role, and so on and so forth. And each one of them effectively becomes a little Terraform island with its own TF state, and it's managed independently. And while that provides us with a certain degree of safety, as Rob mentioned, where we don't accidentally destroy things, it becomes very difficult to accidentally destroy things, it also increases the complexity of managing it in the first place. So
yeah, absolutely. But I remember the thing that made me think was you're talking about parallel, because one cool thing about having it split up is we could easily script it to run every apply parallel, right? We could modify them all, run apply parallel. The problem we hit with that is AWS rate limit. It's if Terraform fails because of an AWS rate limit, then it's pretty much just random where it failed. So that's where the dangling, all the stuff we talked about earlier, the dangling resources, all that stuff. that's one of those failure cases of data that's really awful.
That's
It's
not,
like, I'll be
that's not
smart and
Terraform's
I'll,
fault.
yeah, no, not
It's not
Terraform's fault at
Terraform's
all.
fault. It's
No. But yeah, it would be nice if it could. I remember reading the Terraform issue about this. And, the way AWS does rate limiting is not very friendly compared to like GitHub or something. It doesn't tell you how long you should back off for or what your current count is or anything. It's just like, you're just over limit. Like, try again some other time. You know? So it'd be, I mean, I guess Terraform could have some kind of exponential backup of its own. I think that was discussed in the issue. So I think Terraform could, it's not Terraform's fault at all. I think Terraform probably could do something about it.
Yeah, we talked about that. That's something we definitely want to add. And we kind of have some idea of how we'd like to do it. I think we get a little bit of a side bonus by switching to upstream. AWS SDK Go does have some exponential backoff built in. So the next version of Terraform should just get that, which is, it's kind of dumb. Like, it doesn't, it's not like sort of scoping it like the overall attempts down based on what we think that Amazon's throughput is, and nothing smart like that. It's just like, if you get an error that looks like this, exponentially back off and retry up to this many times. So that'll help a lot, I think, for no effort, hopefully. But yeah, that's something. Terraform is in an interesting position to solve a lot of problems of that nature.
Right. Yeah, it should definitely be possible to detect, like, oh, what kind of failure is this? An intermittent failure? Then we should retry it. If not, if it's something like AWS saying you can't do that, like you just can't do it, but like a launch config, like, yeah, there's no reason to retry that. But
computer says no.
Yeah, AWS says you can't do that. But actually, turns out you have to use ID there, not name. That sort of thing.
Yeah, we're finding all sorts of. I mean, my favorite joke is that we're sort of like, Terraform core team is like becoming experts in the minutia of cloud APIs with a side effect of happening to write Terraform as an app. Like, all we are just like learning about so you responded, you created that resource, but it's not actually going to be there for another 3 seconds. I see. Right. Like, so you accept a list here, but the list has to have one, but it has to be a list. I see. All sorts of that stuff is like what I spend my day doing, and that's like that's why Terraform's great, that it exists, because it can just paper over that stuff a little bit.
Yeah, thanks for taking one for the team.
But yeah, there's a lot of railing on VPC versus EC2 Classic. That's like an internal switch in APIs that like changes behavior everywhere. It's awesome.
Yeah, I learned a lot when we were in IRC talking about that. You pointed out that the EC2, we were not using the VPC.
Yes.
I learned a lot about VPCs and EC2 Classic that day. a lot, more than I ever thought I wanted.
Strictly speaking, necessary.
Yes. It was funny because that was the situation where. So here's something where Terraform could not. I don't think Terraform could. Maybe if you hard-coded this, it could fix it. So there's this situation where, like, with security groups in a VPC, you pass the ID. In Classic, you pass the name to the autoscope. Right? So everything will apply. It will accept it. When it's time to scale, the autoscaler will throw a really weird error about how security group isn't like a valid parameter.
Mm-hmm.
And it was like that was the worst bug I think I've encountered so far. Where I'm just like, I don't even know where to start with this.
Yeah, where like the validations aren't pushed up to launch configs, so you can actually create a template that's invalid, and it won't tell you until it's silently in the background trying to scale and failing. Yeah.
But there's no way that would have shown in the plan or in like the apply. Like there's no, Terraform has no idea that's gonna.
Terraform's like, well, AWS said it was fine, so it's up there. Yeah. I mean, we're learning a lot of lessons like that, and like it's totally within, I think, the role of the project to expose those up at the Terraform layer by reconfiguring how. Like, I think what we did for at least on the security group side is we just split those out into 2 parameters at the Terraform layer, and if we detect that you're in Classic or VPC, we just make it a validation error one way or the other. I don't know if we're finished with that. I think there might be sort of an outstanding PR, but we're philosophically speaking, we're not sort of like married to the underlying APIs. We sort of use those as a starting point and then sort of model on top of that, doing whatever we can to make the UX better. So
that's cool. Yeah, because there's a lot of little gotchas in EC2 Classic versus VPC, and if you mix and match, like it's nice. So yeah,
I don't think we'll go so far as to like, doing mirroring down like regex like validations of fields or anything like that. But at least in the important places that we can add behavior at the Terraform layer to make less sadness upstream.
Yeah, that sounds great.
Speaking of learning, because we're Mozilla and we like to share, all of our code, and that includes our infra code, is sitting on GitHub. Uh, and that's the stuff we're actually using. That's not there as a demo. We're deploying from that. It's all, you can take a look at it. Maybe we can share the link afterwards or something. But is anyone else that's on the call in a position to share their Terraform configurations or Packer configurations and stuff like that? Because it'd be interesting to see. We can talk about it. Talk about it is great, but it'd be interesting to see actual code. Like what does this actually look like in other people's organizations? We only know how it looks in our organization.
Yeah, I intend for ours to be open sourced. I have a couple of constraints around that, and plus, like our Marathon plugin just needs to be a little bit more hardened before like we go out there. But yeah, like at the end of the day, at least what stands up Mesos, so I hope to be out there in the wild, right? Because we've hardened that pretty well. That's where we're at, right? It's not out there in the wild yet.
And I know Brandon was sort of looking to start to curate Terraform modules, and we worked with him to sort of start an unofficial GitHub organization. It's called Terraform Community Modules. For those of you who don't know, it's a Wild West. So if you want to contribute there, you can. But I think that's a good. I've found already a lot of modules that I use on a daily basis there. And it's different at the module layer, but then at the sort of, this is a full working production infrastructure. I think they're both valuable independently, but it's definitely worth checking out.
I've been curious about that, like the difference between just like plugins out in the wild on GitHub and what you would prefer to like pull into the built-in section of the GitHub code base. Seems to me like once a plugin's at least semi-good to go, that it should just be a pull request into Terraform, so it's in the docs.
Mm-hmm. Yeah, that's been basically our strategy. I think, I don't want to speak for Mitchell, but I think he had this sort of this strategy change back in Vagrant days of basically saying there's a plugin ecosystem, but like there is a top N% of the plugin ecosystem that should just be built in. And I think that's the strategy that we've taken with all the other HashiCorp products, and I think it's worked pretty well. So I fully agree with you that So if any of you out there have something that you're working on, know that we will happily consider including anything into core that you find useful. So because chances are somebody else will too.
Yeah, that's the thing. So yeah, will do. I have another question for you if nobody else does. Provisioners right now run on create. Seems like on update before delete is something that would be very helpful, specifically before delete. Is that something that you guys? I know at one point there was some pushback to like that being necessary that I saw in some of the issues.
Sure.
What that stance on that was.
Yeah, and so that's timely. That's second on my list. So my current list right now is I'm working on. I'm finishing up some graph visualization work that I've been doing.
That looks good, by the way.
So Terraform graph is a command that outputs the current state of the graph in dot format, which is a graph description language that you can pipe into a project called an open source tool called GraphViz and get a full sort of visualization of Terraform's state of the world. That works on sort of the basic case, and I've been enhancing it to spit out all of the. So Terraform internally has a lot more nodes that ended up getting spit out in that graph, particularly the nodes for sort of operations. So Terraform has a node for each sort of potential operation that might happen. So that's the work I'm doing now. Then I'm working on SSH proxy support. So we have a lot of environments where people are using Bastion hosts or jump hosts, right. And provisioners right now kind of are dumb, or they're very simple in the way that they just connect to the node. So it's about indirection in that connection step. And then third is provisioners, promoting provisioners to nodes in the graph. So right now provisioners are a hook as sort of a part of the resource node, and that's what limits their ability to be sort of moved around. And so what we're going to do is promote them to graph nodes, which allows them to be attached to wherever they are useful in the graph. And then we'll add, that's why we made lifecycle in the config a block. Right now it's a block that only has one field in it. And that's where we plan on, actually two, it'll have two. The prevent destroy just landed, which is sort of the, I don't want to ever destroy this resource thing, guard. So yes, we do want provisioners to be able to run on any piece. I think the pushback that you saw in some issues are people who we're really careful for people who think about Terraform as sort of like a auditing daemon that runs in production. And that's we don't want that sort of misconception. Terraform is very much sort of a infrastructure bootstrapping, and it does have a certain amounts of drift detection, but it's not really meant to sort of run every 10 minutes or something like that. Or at least it wasn't designed that way. And so we want to try to help people with their mental model. So people are like, well, I want to detect if the node has changed and then rerun the provisioner. That's what we push back against. But being able to run a provisioner on a specific lifecycle hook, that's definitely something that we're adding.
Right. Cool. Well, I need it pretty soon, so.
So get on that.
Well, that's actually not what I was going to say. So if you need a hand, point me in. It's like I wanted to build something that was aligned with your vision.
Sure.
So, and I have hands to help. So anyway, we can talk about that offline.
Yeah, totally.
Cool.
So Paul, maybe you could shed a little light. What if any, is the future of of Terraform with respect to some of the other stuff that HashiCorp has as an offering? Because the console and there's Pack, and we touched on some of these things, but they're all independent tools. They share a relationship, right? You can put them all in the same workflow, but at the end of the day, they're independent tools. Is there is a direction you're going to start to maybe unify that a little bit, maybe start trying to make that a bit more cohesive, or is the idea to sort of the Unix model where everything does one thing, and then if you chain them together, that's great?
Sure. Yeah. It is very very similar to the Unix model where each tool does one thing, but sort of our vision is to stitch them together in Atlas. So Atlas is our that's our commercial product. The way Mitchell first described it to me is basically, if you all of the tools for building a house are always going to be free, but some people just want to buy a house, and that's sort of what Atlas does. Atlas is stitching together all of the tooling into a unified workflow, and what you get, so we're always we're iterating on Atlas and starting to pull these tools in. So we integrated console recently, and then most recently we have the initial Terraform integration. So if you haven't check it out, you definitely should. The tutorial is really there's an interactive tutorial online, and it's all free to sort of check out. But basically the idea is these tools are really facilitate a really great workflow from an individual developer laptop. What about the collaboration story? And Atlas is sort of the collaboration on infrastructure story. So for each of our tools, you can push to Atlas, and that's where your Packer build will run, your Terraform plan will run, and artifacts are going to be produced. And then there are steps for people to be able to review and check, and then apply the change or push the change or whatever the appropriate verb is for that tool. And so it's really cool. I think we're already starting to see some really interesting experiences come out of that. It's pushing forward that idea of version control for infrastructure. So the source code, in the same way that it's very similar to sort of what GitHub did for version control for code. Those experiences that you see as we're starting to build in Atlas are these collaboration around a change set, right? Around a Terraform plan to say hey, why is this DNS record changing? I didn't expect that DNS record to change when you push this diff. and to be able to say like, oh, okay, we'll throw that one away, push it again. It's like, oh, this is definitely what's going to happen. And then you get the guarantees of a Terraform plan, sort of like as well as the sort of the nicer user experience of a GitHub-like experience of being able to click like, okay, go. So yeah, that's the work we're doing to stitch stuff together and to really smooth out the experience, while at the same time keeping each of the tools like super solid and super well defined with each other. Yeah, it's worked out really well for us so far, I think, the strategy.
Is Atlas ever intended to be sort of like behind the firewall, like on-premise sort of thing? Or is it currently hosted only?
Yeah, so there will be a sort of a canonical instance that we will run for people, and there's some pretty interesting stuff that we can do with technology called SCADA, which is essentially a fancy way of developing a relationship between two otherwise private resources on the open internet. So there are a couple of ways that we've allowed folks who would otherwise want on-prem to be able to establish a secure relationship with something like a cloud resource like Atlas, and let Atlas do stuff like Packer builds and Terraform runs. That being said, yes, we also are going to support an on-prem version for people who want that to be their thing.
That would have to, right?
Right.
Yeah.
That last point, we were just muttering to ourselves here. Allowing an on-premise version of Atlas is interesting.
Yeah, we've definitely played with Atlas. Yeah, I do really like the part you're describing, where you you set up a Terraform remote and it stores your config and your state in Atlas. That solves a really work problem.
Solves a problem we have.
Yeah, we're dealing with it with a wrapper shell script that does an S3 sync, for the state sync, which isn't wonderful. The config one's kind of a problem. Anyone that wants to run it has to have all the config and make sure they get it right for the right environment.
Right.
So that's and you don't want to mess it up. You don't want to like you accidentally use your personal key when you spin up prod or taking like SSH key, for example, or or SSL search or whatever. And in the whole when you the way it shows you the plan, and you can ask somebody, hey, review this plan, click OK, and then have a record of not only that we checked something into the repo, but that it shipped on this date, and these guys, this guy did it, this guy said it was okay, so you can later ask, like, why did you think that was okay? Why did you so we normally don't have that kind of, it's usually a friendlier state than that, even so.
We normally don't have that conversation twice.
Yeah, that's a good point. Yeah. Occasionally there's a first conversation.
Oh, I see. You thought it was wise to drop all of our databases.
Yes. Yeah, definitely. One thing I thought was really cool about Terraform is Atlas, about Atlas and Terraform, is that I wanted to kind of quickly test it out, and I was able to just take one of my existing little apps that was in Terraform in my console app and just get it running really quickly in Atlas. I didn't have to do the Packer thing. Like, I kind of used my own workflow on Atlas and it worked, which I thought was really cool. So I just had it basically just, instead of me running Terraform apply, I was just pushing it up there and clicking a button up there. So, it does look like a really interesting project. So it's really fun. I think the vision behind it, which it's nice to hear a little bit more about that, is really interesting. So I think that would be really powerful. I like the house analogy. I think it's a good one. So
house analogy.
Yeah. If we could buy exactly the house we wanted, that would be a compelling option. I think for a lot of orgs, if they're like, oh, we could just buy the house and stick our furniture in it. Okay, that sounds good. Yeah. So that doesn't seem to be available right now. So as far as you can tell, it's all about building your own right now. So.
Mm-hmm. Yeah, the other interesting, talking about Terraform state, managing Terraform state, sort of in a problem that each organization has to solve right now. An interesting feature that landed, and it's kind of like super early days for it, is the ability of Terraform to extract outputs from a remote state that it does not own. And that presents that's something to keep an eye on for everybody, because it presents some really interesting use cases, particularly for organizations where, or within teams where you want to manage higher value resources separately with separate credentials, and expose only certain details or attributes of those resources. Essentially, what you can do is take a Terraform module and say, this is going to run over here. It's going to produce two DNS, like whatever, two URLs to my database, let's say. And you can have a totally separate Terraform repository that is consuming just those two URLs as inputs. And so, yeah, that'll be something that I think we'll see make some very important workflows possible.
Right. Yeah, I noticed. So it looks like when I was playing around with that, I noticed in the Terraform remotes, it looks like it supports console for storing state and also like an HTTP service. It just said HTTP, so I wasn't sure if that was just like a expecting a certain interface.
HTTP it might be S3 compatible. No, it's not S3 compatible. It's something like that though. I think it might just be like it's super generic of like if you can get a service that can post and get.
Cool.
And then console also has the ability to do locking, which is nice too.
Yeah, could you say that again?
Say that again. It has the capability of doing what?
Locking. I think it's not in Terraform yet, but that's the plan, that we can actually do sort of a mutex to prevent multiple people from making changes to an environment at the same time.
That's really interesting. Yeah, because one thing we were talking about, so we have, we use console, and we have a console cluster for stage, and we have one for prod, and those are spun up by Terraform. So it seems kind of weird to keep our Terraform state in something that we're managing with Terraform. So we can figure out, which obviously is one thing Atlas solves. It gives you different places to push your state to. But but we were thinking about that. Like, is it weird if we stored our Terraform state in our production console cluster that was spun up by that, or maybe have our own, a separate console cluster, or or a separate HTTP service or something. So,
or what we're doing now, which is just copying state files to S3.
Yeah. Which is, works.
Which works.
Well, the thing I'd like to do is not just the state big. That's what would be really cool. Push big sometimes. You didn't have to have, the staging config that had all the cert names and everything's out right. You didn't have to have on your laptop,
Just time file.
With that, I don't know enough about plan files.
No, I think that's the answer to that. Is pushing the time file.
Well, what if you want to do if you want to make a new plan? Does that matter?
Oh, you can't make a new plan. It's carved in tablets and stuff.
Can you use that as input?
Console clusters all the way down.
Yeah, exactly.
Cool.
Yeah.
All right. So we are. We are at the part of the show where we do closing thoughts. Anyone have any?
I have a technical question if it's not too late for that.
Fire away.
So you guys were mentioning how like the ideal environment with Terraform is to have internal environments and production be only differentiated by a few variables. I'm wondering how if you need to have scale be significantly different in those environments in terms of node count. I'm wondering how you address that with Terraform, or if that's something that you have to do manually in how you describe those environments.
I would say that there are overrides for that particular environment and the counts that occur there. So that if you have the same like SHA in UAT and prod as far as like what config you're using, that you can still override the counts per resource type.
Right. Is there any way to have some sort of like order of magnitude representation that is a little more, allows for something more dynamic?
There is
even some
calculations, but I'm not so sure.
Yeah. Okay.
You can always have a wrapper script that just does times 10.
Yeah.
And writes that to the override file.
Yeah. Okay. Cool. Thanks.
My only closing thought is that I appreciate all the hard work that Benji puts into, and everybody at HashiCorp puts into the project every day. I mean, there's 100 issues, 100 things that show up in my notifications a day, even on the weekend. So it's getting more hardened every day. Thank you.
I think we definitely echo that on our side. the level of responsiveness that we've gotten from Paul, specifically, big shout out there, but the rest of the community in general on IRC, mailing list, and recently now on Slack, has been phenomenal. It's a young community, but it's healthy already, right? A lot of the established communities that are out there, especially we've all been in that situation when you're trying to learn to use a new tool and you go into a community and you ask a new question and everybody makes you feel like crap. And that's not the case with the Terraform community, certainly, nor in my experience with the rest of the tools, the rest of the HashiCorp community. It's been very, very positive. So try to stay on top of that, Paul. Maintain good community hygiene, and nip things in the bud, because the community is strong and it's kind, and that's a huge, huge, huge win for everyone.
I concur.
Yeah. So some closing thoughts from me. First, the community I think is good, and definitely hats off to you, Paul. You seem to be the main one focused on sort of the community angle, and that I know Gatsby tends to be a little more heads down in the guts. So folks that want to find the community, obviously the Google group and the Freenode IRC channel are Terraform-tool, right? Terraform.io is the website. If you like Slack, there's also a HashiCorp Slack channel on the Hangops Slack, which people can check out. Signup.hangops.com lets you self-register for our Slack team. Definitely, if you're looking for, I feel like that's more of like a general discussion room for sort of HashiStack enthusiasts. I would encourage people to go to the official IRC channel or the mailing list. I try to keep an eye on both. And what's cool about the IRC channel is you have bot in there, so botbot.me is logging it as well. And as Paul mentioned, we have the GitHub or Terraform community modules, which a lot of it is just stuff I've put up. I'm hoping to have time soon that to update a lot of those to use split, which is new in 0.4. There's a split function, which sort of is like the first way enabling to pass complex data between modules, which should make the modules a little more flexible. A lot of the early stuff I put up was very hard-coded. It was like 2 availability zones, 2 subnets, just sort of like, it was kind of like, hey, I'm writing modules, I might as well share them, because then I want to pull them in as modules from my templates that I'm not sharing, since those are very bespoke. But I want to, it's like module source, I might as well put them on GitHub and source them from GitHub. So those are there. I'm working on upgrading the ASG module to 0.4 with split, and as part of that, I threw together a little shell script for actually running Terraform plan as part of a Travis run. So that's something I'm trying to evolve, kind of like a lint type of a thing. That is one thing I'd, love to see us figure out is some kind of a HCL linting. That would be really cool. And I think, complex data types and variables is probably the biggest sort of ask that I have as a user. So there's that, but I think it's been really cool to see things evolve. I think things are definitely moving fast. There was one other thing I wanted to say. I can't remember. So thanks everyone for your time. Paul, do you want to give any final shout-outs?
Yeah, I just wanted to say it's amazing. This is a huge thank you to all of you who are using Terraform and at this early stage, who are boldly going and trying out this relatively young tool, and then making it better. It is a really healthy community because of you people. So thank you for all of your work, and let's continue to make this thing awesome together.
All right, cool. I think we'll end there. Thanks, everyone. Have a good weekend.